York House is a commercial property with 5 floors, with various occupiers across those floors. Recently, the project to remove the carbon from the building was to remove all of the gas from the office side of York House. That involved in removing 4 gas boilers and installing 2 air source heat pumps and the associated equipment to keep the heating system going.
The project at York House is quite unique because it was our first building where we achieved a full gas removal by using heat pump technology. Our previous projects we've had a hybrid of retaining gas, but this one was really to lead by example as it's our head office and fully remove gas.
Mitsubishi Electric are a preferred manufacturer for British Land across their whole estate. One of the key factors in why we are a preferred manufacturer is our extensive product portfolio. That includes low GWP refrigerant heat pumps such as the IFXQ G05, which has been used on the decarbonisation of York House.
The global warming potential of the chiller units have been dramatically reduced by using the air source heat pumps. That is a big plus for British Land, particularly when we come to try to get the EPC rating as high as possible for the building. So we have a metering system for York House that monitors all the consumption from electricity, water, gas. From the consumption that we use for gas for 22-23 was something in the region of 500,000 kilowatt hours. Obviously, with removing the gas, we've saved 500,000 kilowatt hours on consumption, although there's been a slight increase on electricity usage because the air source heat pump has to do dual heating and cooling.
The challenge around the project was to ensure that we could maintain a flow temperature hot enough to heat the building at all times. To do so, we needed to ensure that we had a method for being able to increase the flow temp at periods of high load, which is why we installed a water-to-water heat pump. The unique aspect of this project was that we had no hydraulic separation and a much lower capacity on the water-to-water, so that we only injected the amount of heat required to give the building the load required during the winter months. The benefits of this were higher operational efficiencies, lower initial capital costs and a simpler installation.
So as part of the project here, we engaged actually to an advanced building model in line with the NABERS standard to identify actually what the peak loads would be. So we came up with a principle and proof that we could actually utilise a 95% peak loads to minimise the equipment size, but also actually to optimise the project costs as well. So we can actually start controlling the building on what's called a demand-driven strategy. So we actually don't allow the building to get cold, but actually allows actually that reduces the time needed to heat up, but allows us actually to maximise the heat pump technology.
Initially, the building was heated by 4 atmospheric boilers equating to over 1 megawatt of heating capacity. The new equipment's comprised of 2 heat pump chillers with a combined heating capacity of 1100 kilowatts and a combined cooling capacity of 1200 kilowatts. The benefits of using the Mitsubishi 4-pipe heat pump chillers is that there's a year-long cooling load and we get to use some of the waste heat from that process to heat the building. We use a CIBSE TM65 framework to calculate the amount of embodied carbon from the project. This allows the client to calculate how long it takes to offset from the operational carbon savings.
Based on the success of what we've achieved at York House, that is now our benchmark for future projects. So where we are looking to retrofit or replace standing assets, we are looking to fully remove gas, so that's now the model that we follow throughout the rest of our standing portfolio.
What we've managed to prove here actually is we can achieve in a building like this over a 400,000 kilowatt hour reduction year on year in energy. And that's not a small feat to achieve that as a retrofit. And that's one of the key successes that we've been able to do here, is to prove that not only have we reduced our carbon, our kilowatts, but also reduced complaints into the building.
The British Land sustainability targets are for a 75% reduction in operational carbon and a 25% reduction in operational energy. And these targets are set to be achieved by 2030.